Okay, let's move on to the question number 2 for tutorial 4b. So the steam enter an adiabatic nozzle. So there is the words adiabatic nozzle. That means it is an isentropic process. What is a constant entropy process? That means at S2 equals to S1. Anything that's inlet equals to everything is out. Okay, so it's inlet at saturated vapor 6 megapascal and expand to 1.2 megapascal. Okay, so the question asks you to draw a TS diagram and determine the maximum exit velocity. So what are the V2? Okay, so low inlet velocity means what? Low inlet velocity means V1 speed equivalent to 0 meter per second. It's very zero. So exit at V2. So we need to find, put head here. So what are the inlet, the maximum exit, the outlet? Okay, given that the pressure outlet is 1.2 megapascal and this one is 6 megapascal. Okay, so as enter leave at one stream, that's mean as similar to the tutorial 2b, which as I explained before last few months. So air is enter and leave on one fluid stream. That's mean the amount of M1 dot here from the inlet also put as 1, or outlet sometimes we can put as 2. So depends whether you want to put 1, 2 or in and out. So M1 dot, M2 dot. Okay, so this is M dot. So the amount of one fluid stream, that's mean the same amount of M dot. Okay, the mass flow rate for inlet and outlet. Okay, so because these are the system, okay, so remember the long equation of first law of thermodynamics: in Q in plus W in, M dot H plus kinetic energy plus potential energy. Oh, okay, Q out, W out, M dot H plus kinetic energy, potential energy, kinetic energy, right? Because there is no effect of heat and work involved in this work, so there is no W in and W out. So leave M this one, this middle here and here. Okay, so that's, so in that case, because there is no potential energy effect involved, so this one also cancel. So leave with this M dot H, M1 H1 and a half V1 squared 2, or equivalence to M1 dot H, M2 dot H2 and a half kinetic energy V squared. Okay, so because the M1 and M dot is the same, so that's why this one is M dot, this one is M dot, so we can move out. So H1 minus H2 equals 2.5 V2 minus V1 squared. So rearrange the equation, we have V1 squared to H1 minus H2. Okay, now we need to find H1 and H2. What are the H1 and what are the H2 to solve this, to get the final answer, which is element. That's it. So then now the challenge is what? The challenge is, now they see that is entered at saturated vapor 6 megapascal. So saturated vapor 6 megapascals means what? So X equals to 1. If you forgot, if you already not remember or forgetting about this, and so that's it is here. Remember that this is compressed liquid, saturated liquid, this one is area of mixture, saturated vapor exactly at this one, and over here is, yes, superheated. So it's exactly here. Okay, because this isentropic process, though, that's mean that S2 equals to S1. Okay, so the value that we got here is the same as the value as S2. So that's why from here, because we need to find H1, so H1 is what? Yes, because exactly here, that means it is at S2. Okay, so from the table, because this is water, again this is steam, so it's water, we can finally, we need to use this thermodynamic steam table. So 6 megapascal. Okay, 6 megapascal. So because it's 6 megapascal. So Hg 2784.3. S is what? Sg 5.8892. Okay, so we got this one. Okay, right. So remember that we need to know that the another particular unknown. So we need to know that what is the next stage is whether it is a mixture or state of compressed liquid, saturated liquid, or superheated. So okay, so at 1.2 S is exit 1.2 megapascal. So S2 equals to S1 because it's isentropic. So that's mean equivalence to 5.8892. Okay, so exit at what? 1.2. So look into this again. Look into the table. 1.2 megapascal. We all know this. Remember that we need to know at least we have at least two characteristic, then we can know what is the state. So 1.2 megapascal, we know that S2 is what? S2 is 5.892. So it's between above or less than ST. So if it's less than 2.21, compressed. Exactly this one, saturated liquid. Above this one or exactly this one is let's say this one is before this, let's say we got the same value, then Sg is what? 6.1, then larger than that is superheated. So 1.2 is what? Is between 2.216 and 6.52. So it's a mixture. That's why, because the S line is straight, so straight line, so draw another one, 1.2 megapascal, so at here. So we already solved the part B. Right, so it's a mixture. Because it's mixture, to calculate the H2 is what? HF plus X, HFG. We need to know the X, because HF and SG you can find it from here. Okay, HF dengan HFG. Right. So once we get the X, because this one is what? So the value we already know, 5.82. SF from the table at 1.2 is what? 2.2166 plus X, SYG is 4.3067. So you got 0.8528. Put inside the value here. Inside here you got a value of 2492. Because we already derived the equation, so we just rearrange the equation. 0 squared minus 2 times H1 minus H2. Kenapa this one is time 1000? This unit is what? Kilo. So you cannot square root of K. Kalau you tak square root of K, dia tak dapat jawapan. So that's why times 1000. Okay, so dapat 763.9 meter per second. Okay, so we solve this question 2 from the tutorial 4A. Good luck.